started the recording. Okay, we're solving 10th assignment today. So, first question, we are having an observable A which takes this particular form. Xi is real positive constant. The eigenstates of this operator A in terms of this orthonormal basis kets phi 1, phi 2 and phi 3 will be this, where A square plus B square is what we need to answer. So what is the first step? What do we do if we have an operator like this and we have to figure out what are the eigenvectors for that operator? What do we do? We need to find out the matrix form, right, of that operator in this basis phi 1, phi 2, phi 3. So A operator is 4 xi phi 1, phi 2 plus 5 xi phi 2, phi 1 minus now how do we find out the matrix form? So A, it's phi 1 and phi 1 inner product. The second element is phi 2 and so on. So it will be a 3 by 3 matrix because we have 3 basis vectors. Sorry, the pen is not working. Okay. So the elements would be, the first element is 0, second element will come from this particular term, so it's 4 xi, third element, this one is again 0, and this will get contribution due to this term, so 5 xi, then these two are 0 and these two are also 0, and this will get contribution due to that, so minus 3 xi. This is clear? Now once we have the matrix, we need to find out the eigenvalues and the corresponding eigenstates. Is the matrix form clear? So let lambda be the eigenvalue, so determinant of A minus lambda equal to 0. And if you solve this, you will get lambda to be minus 3 xi plus 2 square root 5 xi and minus 2 square root 5 xi. So we can find out the eigenvectors corresponding to lambda equal to minus 3 xi. So we get 3a plus 4b equal to 0 and 5a plus 3b equal to 0. So from these two we see a equal to b equal to 0 and c is arbitrary. So the state corresponding to lambda equal to minus 3 xi will be 0, 0, 1. Lambda equal to plus what do we get? Minus 3 xi minus so we get minus 2 square root 5b plus 4e equal to 0, and the same thing from this equation also, from this equating these two also. So b is equal to 2 over square root 5 e. So the eigenvector corresponding to lambda equal to plus 2 square root 5 xi is then, if we consider d to be 2, then e will be square root 5 and c is 0, sorry, f is 0. Okay, and it also should be normalized, so 1/3, okay, is the normalization constant. Square root of 4 plus 5, that's 1/3. Likewise, we can calculate eigenvector corresponding to minus and that will give you the same thing, just that sign will be reversed for the second element. It's 2 square root 5 xi
Madam, for eigenvalues, always we take the real part.
no, no,
If you have an imaginary part in the equations, can I take that imaginary part also?
yeah, if your eigenvalue is coming out to be imaginary, you have to find out the eigenvectors accordingly. Eigenvectors will also be imaginary.
Okay.
Yeah. So basically then p is minus 2 over square root 5q. So the eigenvector now becomes 1/3 2 minus square root 5 0. Now
Madam, how from 2 by root 5, how can I write the 2 stay x, so y, the 2 and minus root 5? Means how can we separate that?
so you make a choice. So you consider P to be 2, if you consider P to be 2, then Q naturally becomes minus square root 5. Okay, so I am taking P to be 2. You can also take P to be square root 5 and accordingly write Q. Then Q will be 5 by 2, and accordingly your normalization constant will be different, but ultimately it will be the same. Yeah, up to a multiplicative constant. So yeah, so that's it. You get what I'm saying? So here I'm
Yes.
considering
Yes.
P to be 2, then Q is minus square root 5, and then you normalize that state, whatever you are getting. So normalization constant here is 1 over 3. Yeah, and the same thing we did here also. We considered D to be 2, so E was square root 5, and then normalization is again 1/3. Okay, now what I was saying is that in this question, the eigenvectors are written in terms of the basis states. So we can basically write that. So eigenvector corresponding to minus 3 xi is nothing but phi 3. So what are phi 1, phi 2, phi 3? These are implied. They are that phi 1 is 1 0 0, phi 2 is 0 1 0, and phi 3 is 0 0 0 0 1. Okay, so eigenvector corresponding to minus 3 xi, eigenvalue is phi 3, and this can be written as a linear superposition of phi 1 and phi 2. So 2 phi 1 plus square root 5 phi 2. Okay, and this is 1/3 2 phi 1 minus square root 5 phi 2. Okay, now the question is, these two coefficients are a and b. So a is 2 a is 2 as we have seen, and b is square root 5. So what is a square plus b square? It's 4 plus 5, right? So that's 9. Okay, that's it. So this we did before also. I hope you remember that this is how you need to find out the matrix form of the given operator, and then find out eigenvalues and eigenvectors. Okay, you should remember this. Like, you need to apply. You might need to apply it in your exam. Okay. The eigenstate of Jx cap with eigenvalue h cross by 2 will be, okay, so now you can see the eigenvectors are actually 4 by 1. So the matrix must be 4 by 4, and that is what that corresponds to spin 3 by 2. So meaning, if so the dimension is 2j plus 1 is equal to 4, then j is 3 by 2. Okay, so corresponding to spin 3 by 2, what is the matrix form we need to find out of this Jx? So what are the states? States are j equal to 3 by 2, m can be 3 by 2, m can be half, minus half, and minus 3 by 2. So Jx, again the same thing. So these are the basis states for us now, and we need to find out the matrix form for Jx in this basis state. So I'll not write all the elements, but let me write first few. let me call it phi 1, phi 2, phi 3. It's tiring. Phi 3, phi 4. Okay, so this is phi 1 jx phi 1, phi 1 jx phi 2, and so on. Okay, now what do we have to do to find this matrix element? Basically jx is what in terms of j plus j minus. So j plus minus is defined as jx plus minus ijy. So jx is j plus j minus by 2. Okay, and we know how j plus acts on a state jm. So that is h cross square root j into j plus 1 minus m into m plus 1 j m minus 1, and likewise j minus acting on jm sorry, this is plus, this is minus. And if j plus acts on the highest state, that is when m equal to j, so m takes values from minus j to j at the step of 1, and this is equal to 0 because you don't have j plus 1 m, right? So m ends at j, so that is 0, and likewise j minus on j comma minus j is also 0. Now these four things we need to keep in mind and then find out these matrix elements. So let's do that. So so here jx is acting on phi 1, and phi 1 is this state. So let's see how it what it gives. So jx acting on phi 1 is,
Madam, can you explain j plus on j is equal to 0?
because if j plus acts on j comma j, the state that you get here is j comma j plus 1, but you don't have m equal to j plus 1, right? M ends at j, so m lies between minus j and j. So if j is 3 by 2, let's say, and when m is also 3 by 2, then j plus acting on that will give you 0. If j is, let's say, half, m is also half, then that will give you 0. But j plus acting on half comma minus half will give you some constant times half comma half. Is this clear?
Yes, madam. And j minus j.
Same thing. So m ends at minus j. When j minus acts on j comma m, it takes m to m minus 1. But you don't have minus j minus 1. That state is 0. So that's why it's 0. So this is j plus j minus by 2 acting on phi 1, and phi 1 is 3 by 2, 3 by 2. So of course this j plus acting on this will give you 0. So it is nothing but j minus over 2 acting on this state, and that is h cross over 2 square root of j into j plus 1. J into j plus 1 is 15 by 4 minus so j minus is acting on this state, so m into m minus 1, that is 3 by 2 times half on 3 by 2 comma m minus 1, that is 3 by 2 comma half. Okay, so h cross by 2, what we get, it's 15 minus 3 over 4, so square root 3. Okay. Now j x acting on phi 2, phi 2 is 3 by 2 comma half. So now both j plus will act on it and j minus will also act on it. So let's take half h cross by 2 outside. Square root j into j plus 1 is again 15 over 4. When j plus acts on it, it gives m into m plus 1. M plus 1 will be 5 by half into half plus 1, by 3 by 2. Half into half plus 1, that is half into 3 by 2. 3 by 2 comma 3 by 2. Okay. So, and likewise when j minus acts on it, you get 15 over 4 minus m into m minus 1. So that is half into minus half, that is plus 1/4. Let me know if I am doing any mistake in calculation. Minus half. So h cross by 2, it's square root 3, and that is plus 2, 3 by 2 minus half. Okay. Jx acting on phi 3, j plus j minus over 2 acting on 3 by 2 comma minus half equal to h cross over 2 square root 15 over 4 minus j plus, so into half, it will become 3 by 2 comma half plus j minus m minus 1, so minus 1/2 into 3/2. Are you following the calculation? Any doubts?
Yes, madam, but Jx acting on phi 1, so that is the j plus acting on 3 by 2. There why it was 0?
Where it was 0?
In Jx acting on phi 1 state. So we are getting the first term is 0, no?
Yeah.
No, why? That it is here, it is 0.
Oh, that's what I was explaining to you, no? When j plus acts on j comma j, it gives you 0.
Okay, okay.
Yeah. So that is m equal to j state. So that's why j plus acting on this gives 0.
Okay, madam.
Yeah. Plus square root 3 by 2 minus 3 by 2. Now the same thing will happen when j plus acts on 5 4. So I mean j minus acts on 5 4. So it is j plus j minus over 2 acting on 3 by 2 comma minus 3 by 2. But j minus acting on j comma minus j gives 0. So you will get contribution from j plus only. and that is h cross over 2 square root of j into j plus 1 minus m into m plus 1, that is 3 by 2 times half j comma m plus 1, that is this. So again you get square root 3. Okay, now you have all these. Now you can easily find out what are the matrix elements. So what is this phi 1 inner product jx on phi 1. So jx on phi 1 is this, but this is not phi 1, right? So let me write this as h cross over 2 square root 3. This is phi 2. Okay, this is h cross over 2 square root 3 phi 1 plus h cross over 2. So basically h cross over 2 appears everywhere, so we will take it common, so that's why I'm keeping it as h cross over 2 and not cancelling this 2 with this 2. This is 2 phi 3. This is equal to h cross over 2 times 2 phi 2 plus h cross over 2 square root 3. This is phi 4. Okay, and this is equal to h cross over 2 square root 3 phi 3. Okay, so then jx equal to, so let me write all these at a single place, so it will be easier for us to see. Jx so on phi 2 on phi 3 it gives this. And so now the matrix jx is so can you tell me now the matrix elements?
Root 3.
The first element.
Root 3.
How?
The h by 2.
Yeah, h by 2 is outside, but first element, is it root 3?
First element. Yes, root 3, madam.
How?
Because jx phi 1 is h by 2 root 3 into phi 2.
Okay, now?
And it is, there is a phi 1 is there.
Yeah.
So phi 1 phi 2 is phi 1 phi 2 is 0, madam. So
the first element is
0.
Yeah, that's right. So these are basis states, they are all orthonormalized. So phi I phi j equal to 0. Delta ij. Okay, now tell me the second element. H cross by 2 I have taken common, so tell me the second element. So phi 1 jx phi 2 How will you evaluate this?
This is root 3
Yeah, how did you do that? So
because we multiply with 5
5 1.
1.
Yeah, so 5
Then it's
1, this
1.
is 0
Yes,
and this
that's
is
root
1.
3.
Exactly, exactly. So you understand now. Now, this, what about this? So Jx on phi 3 you know.
That is 0.
Exactly, because here you have phi 2 and phi 4. So this is 0. And likewise this one. So Jx on phi 4 is giving phi 3. When you take inner product with phi 1, you will get again 0. Okay. how about this one, this term? This term is, so Jx phi 1, inner product phi 2. What is that one?
That is root 3.
Yeah. Then 0. Phi 2 Jx phi 3.
Other will be 0.
This will be 0.
Phi 3.
Be very
Yes.
careful.
Phi 2, phi 3, phi 2. No, madam, it is 2.
Exactly. So you shouldn't close your eyes and do it. Now Jx on phi 4 is giving phi 3. So phi 2 inner product will give you 0. Okay. Tell me the other terms also quickly.
Right.
Jx on phi 1 is phi 2.
No, this is 0.
0. Then
2. Then 2.
okay. 0.
0. Yes.
Square root 3. Okay. So phi 4 0 0 phi 4 Jx phi 3. What about that? Phi 4 Jx phi 3.
It's root 3.
Phi 4 Jx phi 4 0. Let me just check. Yeah. So this is what you should get. Now you have Jx. Now you can calculate the eigen vector corresponding to eigenvalue h cross by 2. Okay. So let's do that.
Madam, it is lengthy question for short question. 1 marks very lengthy.
True. Okay. So eigenvector with eigenvalue h cross over 2. So minus h cross by 2 square root 3 h cross by 2 0 0. 0 h cross minus h cross by 2.
Madam, first term, why it is minus h by 2?
Oh, I'm finding eigenvalue corresponding to h cross by 2. So I'm just subtracting it. Zero, 2 and minus h cross by 2. Okay. So what do we get? The equations, it's minus a plus square root 3b equal to 0. Square root 3b minus, sorry, square root 3a.
Madam, eigenvalue is h by 2.
Oh, the question, let me read it for you. Question is, the eigenstate of Jx with eigenvalue h cross by 2 is what? So eigenvalue is given to you. You just need to find out the eigenvector. But for that you first need to know the matrix representation of Jx as well. So that's what we have done so far. And looking at the dimension of the eigenvector, you have to make sure that, you first realize that the Jx matrix is actually corresponding to J equal to 3 by 2, and then you proceed to figure out what is the matrix form, and then you find out then we are finding out the eigenvector corresponding to eigenvalue h cross by 2. That's what is asked in the question. Is that clear?
Yes, madam.
2c, so that is the other equation. And then third one is 2b minus c plus square root 3b equal to 0. Square root 3c minus d is equal to 0. Okay, so this gives a equal to square root 3b, d equal to square root 3c, then replace a here. So if I replace a, it becomes 3b minus b plus 2c. So that is 2b plus 2c equal to 0, or b plus c equal to 0. Okay, and in this equation, if I replace d equal to square root 3c, then we get b plus c equal to 0 with the same equation. So basically c equal to minus b. Okay, so then a, b, c, d is,
Write it all in the terms of b.
yeah, that's right. Minus square root 3b. Something is wrong. Fine. C is minus b and d is square root 3c and c is minus b, so it's fine. So if we normalize it, we get 1 over square root 3 plus 1 plus 1 is what? Square root, so 1/3.
8.
8? Oh yeah, right, 8. Is the answer, yes, square root 8. 1 over square root 8, square root 3, 1, minus square root 3. I think up to a minus sign it matches with option A. Let's see. So option A, right? You can take minus, you can absorb your minus into the, so eigenstates are still eigenstates if you multiply by some constant c. That's the point. So C, A is the right option. Fine. Third question. Suppose the measurement of Sx was found to be h cross over 2. Immediately after the measurement, we measure Sz. Then the possible results of measuring Sz are h cross over A and minus h cross over A, where A is equal to, can you tell me? is A. So if you measure Z operator, what will you get as the
A is equal to 2, madam.
why do you say that?
It I am thinking about standard like experiment. That is why.
Okay, but what is H cross over 2 for Z operator and minus H cross by 2? What is it? Those two are nothing but eigenvalues, right? So whenever you measure an operator, you will get its eigenvalues. That's what it's
Yes.
asking. So A is nothing but 2.
My HZ also H by H cross by 2 and H minus H cross by 2.
Yeah, so Z
That
was
that that
this we did in our earlier assignment thoroughly. So it was H cross over 2, then sigma Z, and then we saw that the eigenvalues are H cross by 2 and minus H cross by 2, and corresponding eigenvectors were 1 0 and 0 1. Right? So,
yes, madam.
so whenever you measure Z, the possible values that you can get are H cross by 2 and minus H cross by 2. Okay. Now consider this operator, the expectation value of O for this state. Can I do this? So this requires the knowledge that we gained in problem problem 2. Okay, so Jx we can write in terms of J plus J minus as well as Jy, and then the state is given to you. You know how J plus acts on Jm, so you can do this. So let's solve it. And Jy is minus J minus over 2i. So your operator is nothing but 1 over 4 plus J minus J plus minus J minus, that is 1/4, J plus square, J minus J plus minus J plus J minus minus J minus square. Okay, and you have to find out expectation value of this operator for state J is half and M is minus half. This is what we need to find out. Okay, now you know how J plus acts on it. So when J plus acts on J equal to half, M equal to half, that gives 0. This is J, M equal to J state, so J plus has to give 0. J plus acting on half, comma M equal to minus half will give you square root H cross square root J into J plus 1, that is half into 3 half, minus M into M plus 1 minus half times half, J equal to half, M plus 1, that is M equal to half, which is equal to H cross, it's 3 by 4 plus 1/4, so 1, so H cross J equal to half, M equal to half. Okay, so now
I'm always J plus acts on the M state, no?
J plus acts on
M, not the J part, small J. That means that J remains half, but M m changes from minus half to half.
Yeah, j remains half and m ranges from minus j to plus j at the step of 1.
Well, my question, why it is not acting on j to j plus 1?
No, so this is the entire state. The entire state you express like this with j and the corresponding m value, and j plus acts on this entire state, and this is the this is not eigenvalue equation because the state changes, but this is what you get. uh,
Coefficient, that is.
yeah, the coefficient becomes this.
State is the j is always is in the same state, but the m is changes by 1 if it is j plus.
Yes.
Now, why it is not acts on j state? That is the question. Means, is there any significance? Always we
No, j plus does what? J plus is a ladder operator which takes you within this set of, so m equal to j comma m equal to j minus 1 dot j comma m equal to minus j. So ladder operator takes you within this set. So it will not give you something else. I mean, j cannot be anything different.
Okay, madam.
Yeah. How do I explain it better? Uh, yeah, like these are the ladder operators, and they can only take you from within that set. Okay, I'll think about it if I have any other better explanation. So when j minus acts on it, you will not get 0, but you will get h cross times square root half 3 half. So since now j is half, j plus can only give you any state among these four. So this and the other one is can only give you among these two states. So now m can take either plus half or minus half. So that's what we are getting. And if it was 3 by 2, just like before for problem 2, j plus was taking us between those four basis states. So j plus acting on this state gave us phi 2, which was another basis state, and so on. This was linear combination of phi 1, phi 3, phi 2, phi 4, and phi 3, so on. But okay, minus half into m minus 1, so minus half, so 1/4. So h cross now j minus, when it hits m equal to minus j state, that is minus half, it gives 0. Okay, so these are the things that we need to find out that expectation value. So this expectation value then equals equal to 1/4 half minus half square minus j plus j minus j minus square. Okay. Now can you tell me what are we getting? So j plus square acting on this. So when j plus acts on this, that means j plus acting on this particular state, that gives us this, right? H cross. So let's do this. But the only contribution, non-zero contribution that you get is only from this term, second one, okay? And all other terms will become zero. Can you see that already, or should I explicitly do this?
Madam, please explain why j plus term is 0, j plus square. Because that will be squared, no?
So,
So j plus of any that term, j equal to half and m is equal to minus half, it takes to h cross j half m half. So if it is square of that, so can't you take h square the same term?
mm, see, it's creation operator acting twice. It's not one creation operator and again another annihilation operator in the language of harmonic oscillator. But you are acting with j plus square. So what does that mean? When j plus acts on this state, it gives you j equal to half, m equal to half, right? And so now the state that you have is j equal to half, m equal to half, and on that you are acting with j plus again, so that gives you 0. Did you get what I'm saying?
Yes, madam. Yes.
But the thing that you are saying is will be true here. So see what is happening. So j plus acting on this state means j plus acting on this, that gives you j equal to half, m equal to half. Clear? And then j minus is acting on this state. So j minus acting on this state, meaning this one, and that will give you j equal to half, m equal to minus half, and on the left you have the same state. So basically inner product gives you 1. If you look at another term, let's say this one, so j minus acting on this, meaning j minus acting on this, so that's 0, that is 0 immediately, and j minus acting on this is again 0, that is j minus square, but j minus acting once is 0, so anyway it's 0. All the terms are clear?
Yes, madam.
So I'll just write j minus j plus half comma minus half 0 plus, okay, and this gives you, so j plus acting on that is h cross, j minus now j minus acting on, oh sorry, when j plus acts on this, it becomes j plus half comma half, and then j minus acts on that, so it gives you another h cross, so h cross square over 4, okay.
Madam,
Now
what is O plus here?
no, not O plus. I was saying all are 0. Sorry, that was confusing. I was trying to just say that this term is 0, this term is 0, this term is 0. So that's how I wrote, but let's write it this way. All other terms give 0. Okay, so h cross square over 4. So that means, what is q? What is q?
U is 2.
Okay. The Hamiltonian form of a three-dimensional system is given where epsilon is real positive constant, phi 1, phi 2, phi 3 form an orthonormal basis. If a normalized state of the system is this, then matrix element or the expectation value of H with respect to that state is what? Can you do this? We have done this type of problem several times. You can do this, right?
Yes, madam.
Then do it and then tell me. Could you solve? First of all, you can tell me what are you getting when H operator acts on the given state psi. So, and then we can take inner product of that state with the given state to get that matrix element. So what I mean is, what are you getting for this part? So when H acts on state psi, what do you get? Okay, this acting on minus phi 1 minus okay. So this when hits this particular term and this particular term, we get non-zero value, and that is nothing but minus epsilon over square root 2 phi 1 coming from this term, and when this hits this particular term we get plus square root 2 epsilon phi 2. Is this clear?
Yes, madam.
Now for this term it has to hit this one to get non-zero value, and that gives us plus I 2 over square root 3 epsilon phi 1, and likewise this one has to hit this one, so plus I square root 2 over, sorry, this is 9, square root 9 over 3, that's 3 over 2 epsilon phi 3. Is this correct? Now we take inner product with psi again, and that gives us, so let's write these two together, this term and this term, that is 2I over square root 3 epsilon minus epsilon over square root 3 phi 1 plus square root 3 epsilon phi 2 plus I square root 3 over 2 epsilon phi 3. So when we take inner product of this state with this one, so I'll just write the result. So it's minus 1 over square root 2 times this term 2I over square root 3 minus 1 over square root 2 epsilon, then minus, oh sorry, let me write that thing, otherwise we may end up making mistake. So when I take dual vector, we have to keep in mind that we have I here, so we need to change the sign of that term, these two terms, okay? We can't make mistake there, otherwise the answer will come out wrong. So phi 1, then this becomes plus I over square root 3 phi 2 minus I over square root 6 phi 3. Okay, then inner product, I'm not writing it again, or maybe I can wait. Inner product, this state, okay, so that gives us, let's now solve it. Minus 1 over square root 2, 2I over square root 3 minus 1 over square root 2 epsilon plus square root 2 over square root 3 epsilon I, and the last term is this multiplying this, so I square minus 1, and then there is 1 minus, so plus, it's half epsilon. So this is equal to minus square root 2/3 I epsilon plus epsilon by 2 plus square root 2/3 epsilon plus epsilon by 2 epsilon. Clear? Any doubt? Is this clear?
Yes, madam.
Okay, good. So then what is B? B has to be 3. Okay. So you know the procedure very well. Just if this kind of questions come in your exam, then
Where from we get the 3? B equal to 3?
so the question is saying the matrix element is B epsilon over 3 and we are getting epsilon. So then what is B?
B is equal to 3, okay.
Yeah, that's right. So if 3 gets cancelled out and you get epsilon. The expectation value of this operator of spin 1 particle in state in the state S comma M is 3 h cross squared for any M. So for any M, if we take expectation value of that operator, what do we get? Is this true or false? What do we get? The eigenvalue? Not the eigenvalue, I mean the matrix element. What do we get for this matrix element? Expectation value. So S operator acting on S comma M state gives M h cross that state. Okay, so this operator when acts on this state, we get M h cross plus h cross z minus h cross z. Now again z when that acts on S comma M, I will get again M h cross. And then it gives M h cross minus h cross. Okay, so this is no way 3h cross q. It has got other terms, as you can see. So the answer is false. Fine. A system is described by the following wave function in cylindrical coordinates, where B is a real positive constant. What is the normalization constant? A. Can you do this? What do you have to do first of all to find out normalization constant? How do we normalize the wave function?
Yes, we integrate the psi into psi star.
Yes, okay, psi star psi or mod psi squared over the volume element from, yeah, so that is equal to 1, and then you find out what is this A.
Yes, ma'am.
Can you do this for this system? Now remember this, the coordinate system is cylindrical, so you have to integrate over d rho, d phi, dz, and z runs from -2 to 2. Okay, and rho, you know, limit 0 to infinity, and phi runs from 0 to 2 pi in cylindrical coordinates. So what do you have to do? I'm telling you, psi star psi dv. Now for cylindrical coordinates, it's okay. Let me do that. So psi star psi, when you do it, becomes mod of a square. then exponential minus rho over b. Okay, then v dv is nothing but rho d rho d phi dz. Now it wave function is this only for mod z lying between minus 2, sorry, mod z less than equal to 2, that means z lying between minus 2 and 2. Phi is equal to 0 to 2 pi as in cylindrical coordinates we know, and rho from 0 to infinity. So this is what you need to do. Can you do this integration and tell me what you are getting for A among these options? Let me know if you have any difficulty anywhere, like you know this will give you 2 pi, you know how to integrate this, and this also you should know.
The integration of e to the power minus rho by b
Yeah.
into rho d rho, how we will do?
You know that gamma function integration? This formula you should know. I mean, we used it in our previous assignments, but you should remember now that exponential integration 0 to infinity exponential minus x to the power n minus 1 dx is equal to gamma n, that is nothing but n minus 1 factorial. This is what you need to use there. So consider rho by b to be some other constant p, let's say. Then your rho becomes p times b and d rho becomes dp times b, and then that rho integration takes this particular form with factor of b, I mean b square will remain outside, and then that integration will take this form, and you can do this. So basically you need to use this particular formula, and you should remember this. Now can you do it? What are you getting for this rho integration? So you are considering, as I said, consider rho over b to be some other variable p. Okay, so that implies rho equal to b times p, or d rho is equal to b dp. Okay, now this implies your integration, which is, this becomes exponential minus p, okay, b times rho, b times p, I mean, dp. So this is equal to b square exponential minus p dp. So what is the power of p? It's 1. So that is nothing but 2 minus 1. Integration is from 0 to infinity. So this is what? B square times gamma 2. Gamma 2 is nothing but 1 factorial, and that's nothing but 1. So you get b square. So that means that integration is giving you b square from row integration. Phi integration is giving you 2 pi, and z integration will give you 4. Okay, so mod of a square is equal to 1 over 8 pi b square, or a is equal to 1 over b 2b square root 2 pi. So let's see, 2b square root 2 pi, which option? Option C, right? So option C is your normalization constant. Fine. Okay, I'll move on to next one then. Okay, now you have to tell me this one. Probability of getting SZ measurement as h cross by 2. So your system, your particle is in this particular state. What is the probability of getting SZ measurement h cross by 2? We have done it many times, this type of problems. So what do you have to do? Just tell me the procedure. How do we find out the probability? Of getting a particular measurement? You first need to find out the probability amplitude, then mod square of that probability amplitude, right? So how would you calculate the probability amplitude? So your system is in the state psi 1 minus I. So probability of getting SZ measurement h cross by 2, what does that mean? That means the final state has to be 1 0, because 1 0 is the state which is the eigenstate of SZ operator with eigenvalue h cross by 2. So that means you need to find out mod square. So this is your probability of getting SZ measurement h cross by 2. Is this clear to you?
Yes, madam.
Mod of 1 0 that is 1 over square root 3, sorry, 1 over square root 6 square root 3 minus I mod square. So 3 plus 1, that's 4. So 2/3 is the probability. Okay. I hope you understand. Okay. What is this quantity? Okay, if this quantity is alpha h cross q, then what is alpha? Can you do this? So this is 1 0, so j is 1, so n can take values from -1 to 1, that is -1 0 and 1. Okay, so that is a commutator, so j plus square jz minus jz j plus square okay. Now this is 0 as you can see, so basically alpha is 0. Sorry, I wrote the same thing. Fine.
Yes, ma'am.
So understand the logic, right? Because jz when acts on m comma 0, so jz acting on j comma m, this state gives you m h cross j comma m, okay, and the same thing is happening here also. Because m is 0, so jz acting on that state will give you 0, and that's why alpha has to be 0. Fine. Okay. Consider a spinless particle with orbital angular momentum. So spin is not involved in the problem. You have orbital angular momentum L equal to 1. The Hamiltonian of the particle is this. The commutator of the Hamiltonian with z component of angular momentum is, if it is this, then what is b minus a? So all we need to do is find out the commutator, and that's pretty simple, right? It's Hamiltonian with the Lz, and we need these formulas that Li Lj is I h cross epsilon ijk Lk. Okay, so Hamiltonian is u Lz square minus v times Lx Ly plus Ly Lx comma Lz. Okay, now Lz commutator with Lz trivially 0, so this is equal to commutator of Lz with this term, so let's take minus v outside, Lx Ly plus Ly Lx commutator Lz, or we can break it up into two terms, equal to minus v Lx Ly comma Lz plus Ly Lx Lz. Now we can break it further up, so Lx Ly Lz plus Lx Lz Ly coming from that first commutator, and likewise two more terms will come from the second one, Ly Lx Lz plus Ly Lz Lx. Okay, now this is equal to minus v. Okay, now what is Ly Lz? From this we can see is nothing but I h cross Lx, and what is Lx Lz? That is nothing but minus I h cross Ly. Okay, so these are the two things we need to use. So let's keep I h cross outside. So Ly Lz is Lx, so Lx square. Lx Lz is minus Ly, so minus Ly square minus Ly square plus Lx square. Okay, so 2vi h cross ly square minus lx square is what we are getting, and that is equal to, given to be, a lx square plus b ly square. So you can see b equal to 1 and a equal to minus 1. So b minus a is 2. Clear? Any issue anywhere? No issue, right? Okay, if not, then we can stop here and see you next week.
Bro, what type of question are asked in the exam?
The questions that we are solving, pretty much this type of questions only. You will get this kind of questions only. Yeah. Whatever we are solving in the assignments. Like that probability question. Your system is given in a particular state, and then you are asked what will be the probability if a particular operator is being measured and that eigenvalue of that operator is also mentioned. So you know what is the final state. You calculate the probability amplitude and then calculate mod square. And then calculating different commutators. So you know the commutation relation between the angular momentum operators Li, Lj. So involving those, you may have questions. And from the initial assignments, we solved particle in a box and Dirac delta potential. Those things you should do very well. Yeah. And then that related to spin, we solved quite a few problems in the last assignment. You should understand those very well, because those kind of questions might come. Those concepts are important. Okay. Yeah, we are almost towards the end of our course, so 2 more sessions are left. Yeah, so we have covered almost everything. I think the angular momentum, algebra and the Klebsch-Gordon coefficients are remaining, so those we will solve. Yeah. Okay. So let's stop here. Okay. Meet next week.